Please like this video and subscribe to our channel. Click the bell beside it for notification. Thank you. In our previous video, we treated simple quadratic equation using the method of factorization. But today we want to look at it using perfect square method. The perfect square method, simply put, is a situation whereby the value of x assumes a perfect square. Instead of being two different values, it becomes just one value. A square of one value can express to become this expression. Now, for instance, this expression now, if you look at it, we find out that if we solve it by factorization, quickly let us run through that. X squared plus, what can we add together to make plus 6 and multiply to be 9? We can have 3 and 3, plus 3 and plus 3. 3 plus 3 will be 6x, and 3 times 3 will be 9. So 3x plus 3x plus 9 equals 0. And we can now factorize this 2 by 2. So we say x comes out, then x stay inside, then another 3 here. Well, we have 3 out here, and then x plus 3 here equals 0. Now we carry the ones outside, pack them inside one parenthesis, while we pack the other one inside parenthesis. If we look at it now, this is x plus 3 multiplied by x plus 3, which is the same thing as x plus 3 square. Now, it means this expression is a perfect square of x plus 3. Now, it proves to us that this can be a perfect square. But how do we really know well that it's a perfect square? Now, to finish this, first of all, before we go to using perfect square method to solve, now we say x plus 3 equals 0. Then we have x is equal to minus 3. So x is equal to minus 3, and this can express, if you express this by expansion, if we find out this answer. Okay, now we want to look at this using perfect square method. Now, what is perfect square? Let's make a simple explanation here. Looking at a general quadratic equation, this general quadratic equation, ax squared plus bx plus c equals 0. Just like this, you see that this is an example of this, or this is a real situation of this, where a is 1, b is 6, and c is 9. So let us look at this as a quadratic equation being solved by the means of perfect square method, just to explain perfect square in theory. Now, we have to reduce the coefficient of x squared to 1. Therefore, we go ax squared all over a plus bx over x plus c over a, bx over a. Now, a and a will give us x squared plus b over a, x, it's all the same, then plus c over a. I want to transfer c over a to the other side because we need to use something that will complete this square, this perfect square. Now we have x squared plus b over a, x, equals minus c over a. Now b over a is the coefficient of x in this expression. Is the coefficient of x in this expression. Now we need to find something at the end of this to complete this perfect square, and that method is called completing the square. Now we have x squared plus b over a, x, plus half of b over a. the square of the half of b over a will complete this perfect square for us. Now we have half of b over a all square. That is what we need to put in this equation to make this a perfect square, to make this section a perfect square. And then we have it as minus c over a. And it's minus c over a. We cannot just add something to this part of the equation without adding the same thing to this part of the equation. It will not balance the equation. So let's balance the equation by putting the same thing at this side of this equation. 1 over 2 into b over a all square. So it balances out. Now we have x squared. We want to express this in a more simpler way. B over a x plus b over 2a all squared. If you use 1 times b is b, 2 times a is a, then all squared. Now we have equals minus c over a plus, the same thing applies here, b over 2a all squared. Now this is what we want to do. By this now, all we just need to do is open a bracket, write x, put this sign, not this one here, and then put b over 2a here, and then square equals c minus c over a plus b over 2a squared. Now we have expressed this part, this expression, as a perfect square. Now it is a complete square here. Now this one will now augment it to make us able to find the value of x. Now you may not understand this until we finish up with this expression, but for now let us leave it like that and use this same method to solve this question. Now, since the coefficient of x here is already 1, all we need to do is just to continue expressing. We skip this part. We skip this part and then we go ahead to this part. What do we need to do? We carry this 9 to the other side. So we have x squared plus 6x equals minus 9. That stays. Equals minus 9. Now we need to break this so that we have a perfect square here. X squared plus 6x plus 6 over 2. That is, we are squaring the half of the coefficient of x. So 6 over 2 all squared equals minus 9 plus the same 6 over 2 all squared. Now we have x squared plus 6x plus 6 over 2 is 3. 3 squared equals minus 9 plus 3 squared. Now we have x squared, or we say x into brackets plus, you pick this plus, then you pick the 3 all squared. Since we have x squared here and 3 squared here, so we just carry this one and carry this one and cover them with the square. Then we have minus 9 plus 9. 3 squared is 9. So we have x plus 3 all squared equals minus 9 plus 9 equals 0. Equals 0. Now we have x plus 3 equals 0. Just like as we have had it when we do it by, just as we had it when we did it by factorization. Now at this point we have x equals minus 3. T is a perfect square. X plus 3 and x plus 3, a perfect square. So that is how to use perfect square method to solve. Instead of looking for what you multiply to get one and the same thing add to get another, you can just use the method of the perfect square. And if actually that thing is not a perfect square, you still get your answer. Now, since we have dealt with a perfect square using completing the square method, now we want to see how we can use the same completing the square method to deal with a question of quadratic equation that is not a perfect square. Now, this one is not a perfect square question. We'll get to know. If you don't know now, we'll get to know as we go on. Now, we'll realize that this question now, it may not be easy to find by factorization the solution, because I don't see anything except a fraction that I can multiply together to find 6, and we can add them together to also get 6. So by this, I say we try the completing the square method. To do the completing the square, we send the 6 to the other side first of all, to be x squared plus 6x equals minus 6, because we are sending this 6 to the other side. Now, we find a way to make this expression a complete square. Now, plus 6 over 2 squared. If you notice, we are squaring the half of the coefficient of x. 6 divided by 2 will be half of 6. Then we want to square it. That's what we're doing here. So the same value that we are adding to this expression must be added to the other side of the whole expression. So we have x squared plus 6x plus 3 squared, because 6 divided by 2 is 3, equals minus 6 plus 3 squared. Now, since we have x squared here and 3 squared here, we can do x plus 3 all squared equals minus 6 plus 9. From this point, we go x plus 3 all squared equals 3, because 9 minus 6 will be 3, or minus 6 plus 9 is 3. Now at this point, we can now find the square root of both sides. Find the square root of both sides to get x plus 3 squared square root of 3. Square root of x plus 3 squared equals square root of 3. Now this will cut this out to get x plus 3 equals root 3. Notice that every root carries plus or minus here. Then we have x plus 3 equals plus or minus square root of 3. Now, x equals plus or minus square root 3 minus 3. When we pick this 3 to the other side, now we have x, if we rearrange it, minus 3 plus or minus root 3. If you use your calculator, you can get it as minus 3 plus root 3, or x is equal to minus 3 minus root 3. These two will be the values for x. That is simply how to solve by completing the square. We want to solve this question, this same question, by using the general formula. Recall the formula. X equals minus b plus or minus root b squared minus 4ac all over 2a. That is the general formula. Now, using this general formula, you have to know that a is 1 from the expression, the coefficient of x squared is a, and that is 1. The coefficient of x is b, and that is 6. And the coefficient, and the one without variable, which is c, is 6. Now apply these values. Applying these values in the formula, we yield x equals minus 6 plus or minus square root 6 squared minus 4 times a, that is 1, times c, which is also 6, all bracket, all over 2 times a, which is 1. Go. We now go to x equals minus 6 plus or minus 36 minus 4 times 1, 4, 4 times 6, 24, all over 2. Then we have x equals minus 6 plus or minus square root of 12, all over 2. Now we go, x now equals minus 6 plus or minus square root 4 times 3 in order to reduce the contents. Then we go to x equals minus 6 plus or minus root 4 root 3 over 2. Then it gets to x equals minus 6 plus or minus 2 root 3, because the square root of 4 is 2, all over 2. Then let's factorize 2 out. From this expression, we can factorize 2 out. From x equals, I'm rewriting, from x equals this, all over 2, we can factorize 2 out of the numerator. Then we have 2 into minus 3 plus or minus root 3 over 2. Then 2 we cut 2. Then we have minus 3 plus or minus root 3, which is equal to x equals minus 3 plus square root of 3, or x equals minus 3 minus root 3. The same question, the same answer we got when we did the other one, when we used the other method. So the completing the square method, the general formula method, and also the factorization method arrive at the same end. Thank you very much.